Thanks for the love, Kevin. And Cecile, the mic is yours. Thank you.
Welcome to Quantum Photonics. So here we are with a very exciting episode with our very special guest speaker, Dr. Douglas Guilbeault. And please try to tag your friends because I wasn't the one who opened the room, so maybe many people don't know that we have opened this room already. So yeah, thank you so much. And anyway, we are this is a very relevant topic in view also for us, the general audience, because of the recent issue with the Google Gemini, which was too woke. And there is this very relevant paper that our speaker has for us to discuss with great slides. And so we are witnessing a pivotal shift in how we perceive and interact with information online. The rise of visual content on various digital platforms, from social media to news sites, has undeniably altered the landscape of communication. However, what may appear as harmless scrolling through images holding profound implications, especially concerning gender biases. Recent research conducted by Professors Douglas Guilbeault and Solène Delacour from Berkeley has sheds light on the pervasive gender stereotypes perpetuated through online imagery. Their study, published in the prestigious journal Nature, unveils a disconcerting reality. The visual content we consume is significantly amplifying gender biases compared to textual information. In a series of meticulously designed experiments and observation, Guilbeault and his team, alongside with their collaborators, delved into the depths of online platforms, scrutinizing the portrayal of gender across various social categories. Their findings revealed a stark contrast between text and images. While text slightly favors men, the bias in images is over 4 times stronger, indicating a pronounced skew in visual representation. What's even more alarming is the psychological impact of these biased images. Participants exposed to the gender bias imagery exhibited significantly stronger biases even after 3 days, highlighting the enduring influence of visuals and on our perceptions. The implications of this research extend far beyond mere statistical analysis. It prompts us to confront the outsized potency of images in shaping societal attitudes and stereotypes. As online spaces increasingly rely on visual content, understanding the mechanisms behind gender bias becomes paramount. Moreover, the study opens doors to a broader discourse on embedded biases in online imagery. Unlike text, which can be modified for neutrality, images inherently convey demographic information, making it challenging to address biases effectively. And so here in this, because one of the biggest bias is also gender bias, I would like to say that this is a very significant start of our March, March being an International Women's Month. So I am very proud and very excited to present to you our very special guest professor, Douglas Guilbeault. Douglas, welcome to Quantum Photonics.
Thank you so much for having me here. That was such a wonderful introduction. And you're right, March is Women's Month, and this is just extremely timely in light of our findings. And also, I couldn't believe that what happened with Gemini came out just days after. The timing was really quite remarkable. So I'll be quite excited to talk about how our findings relate to that. So, is the best way, Cecil, because I see that you've posted at the top, there's a PDF for my slides. Is this something that folks can have open on their end? So would you like me to give a short talk about this, and then we can open up until discussion?
Yes, thank you so much. Yeah, we usually start our event with yeah, some presentation using slide like yours and generally talking about your work. And so after that, we try to open the floor for questions and answers and also discussion.
Okay, wonderful. So um, I assume that folks have the slides open. If not, I hope that what I say will give you the gist of what I'm talking about. So the first slide you'll see, and you can see the number of the slides in the right corner. So the first slide, I just want to give a shout out to my amazing team. I'm so grateful to work with. So as Cecil mentioned, this was co-authored with my colleague at Berkeley Haas, Glenn Delacour. But also it's a highly disciplinary team, interdisciplinary team. So we have a physicist, Ethan Nadler, a computer scientist, Tasker Hall, Bhargav Desikhan, and then also actually a fine arts painter on our team, Mark Chu. So I'd be happy to talk more about how we managed to get this delightful motley crew together. But for now, I'll dive right into the results. And so on the second slide, I just want to start with a broader cultural statement, which is that coming out of the postmodern era, we actually put a lot of emphasis on textual communication, text as the primary way to study human culture and the human mind. So you had, philosophers like Jacques Derrida with these grandiose statements like there's nothing outside of text, essentially, when trying to study people. And we can see the apex of this thinking has just emerged when we look at these large language models like ChatGPT from OpenAI, where people would argue whether these models can be conscious. Now, the reason why this is interesting is because this would suggest that an AI can become conscious purely based on textual information, learning the co-occurrence patterns among words and text. And so this just highlights that many people are still very much thinking this way, a very text-centric way of understanding people. If you go to the third slide, I'm highlighting that there's this cultural trend happening alongside these developments, which is actually a stark rise in use of images to communicate. So just the sheer number of images has skyrocketed online, and people are spending less and less time reading text and more time viewing images. There's some studies from the American Arts and Academy of the Sciences indicating this. There's some research from the tech industry, but also you see software and social media companies like Facebook and that at one time said that they've been seeing a year-by-year decline in textual communication and a stark rise in use of images and videos to communicate. This is also showing up in the advertising world. So news agencies and advertisers are increasingly relying on images to grab people's attention. And I'll say a little bit more in a moment about why. It's because images turn out to be especially powerful in terms of grabbing people's attention and activating their beliefs. And we can also just see that millions of images are downloaded from platforms like Google, Twitter, and Wikipedia. There's good evidence of that. And this is not to mention the rise of hypervisual social media platforms like TikTok, Snapchat, and Instagram, where people almost entirely communicate using visual content. Now, I bring this up because this really raises this critical concern around how does this shift away from text towards visual communication impact our beliefs? And in this paper, we focus on its implications for gender bias. So actually, there's a good amount of work looking at gender bias in text online, and it has consistently found that gender bias appears to be decreasing. So there's a reduction of gender stereotypes and bias in describing social categories and other aspects of our world. But we thought to ourselves that there are ways in which textual communication can reduce gender bias pretty easily. So you think about it could either remove gender from the sentence or use gender neutral pronouns. So if I say the doctor administered the test, I haven't said anything explicitly about the doctor's gender or race. You might have your own ideas, but I'm leaving it up to the reader or the recipient of that message. And there can be differences in the kinds of impressions that people create. By contrast, if I show you an image of a doctor, like what you would get from Google image search, you don't have this ability to dial down gender if you want. In fact, you see that information relating to the demographics are baked into the image. We don't know exactly, like we can't say the objective gender per se. We don't know exactly how that person might identify and so forth. But there are cues that get us to think about what the gender is, even if that wasn't the intended message. So there's a way in which images amplify the presence of gender when we look at representing people. And if you go back actually to the emergence of photography as a popular consumer technology, people like Frederick Douglass, the eminent civil rights organizer and writer, he noticed that this was going to have major implications for bias. So here he says, the great cheapness and universality of pictures must exert a powerful though silent influence upon the ideas and sentiment of present, and future generations. And what I really like about this quote is it highlights something that has actually become the basis for a really productive body of research in cognitive science. So on slide 6, you'll see that there's actually quite a lot of burgeoning research that's actually been accumulating over a couple decades around what's called embodied cognition, or just more generally, this fact that we categorize and understand the world not only through words, but also through images. And the embodied cognition finding that's been robust and particularly compelling is if you, say, use brain scans, but there's also behavioral measures, to look at how people process meanings in textual information, you consistently see that they actually activate images within their mind of a sensory motor nature. So what this suggests is that images are actually foundational to how we understand text itself, which would suggest that images might be particularly powerful or particularly sticky. And one example I like to give is, most of us have some experience like the following, like say you've read Lord of the Rings or you've read Harry Potter, and you might in your mind have your own idea of say what Harry Potter looks like. But then as soon as you see the movies and you see Daniel Radcliffe, that's forever how Harry Potter will look in your mind, right? As a sort of it's so sticky, right? It takes over that mental imagery. And it turns out there's been this replicable finding in cognitive psychology that really demonstrates the stickiness of images. It's called the picture superiority effect. So this is a wide range of studies indicating that at a psychological level, images are processed more quickly and more memorably than textual representations of the same situation, and they're also more emotionally evocative. And this really got us thinking that these properties of images, as a sort of this intrinsic difference, that images might make images especially powerful for communicating information relating to stereotypes. And so we focused on gender bias. This gave us two hypotheses. The first one was relating to that first part of my argument that the presence of gender is just intensified in images versus, say, the description of a person in text. So we argue that gender bias will be more prevalent in the distribution of online images compared to text. So whatever bias we would see in text, we would expect that to be stronger in images because that coupling, the presence of gender is just more frequent in images. And then the second hypothesis is that when people are exposed to images rather than textual information about social categories, this is actually going to do a stronger job at implanting or reinforcing this gender bias. It'll more strongly amplify it in people's beliefs. And we demonstrated that through an experiment I'll elaborate. And I just want to emphasize that we talked about in the paper two ways in which images amplify gender bias. So one is the exaggeration of demographic associations within categories. So say if a category like nurse is female typed, we expect that the extent to which it's female typed will be stronger in images than text. And we also look at, if we zoom out, look at across all categories. So not just nurse, but all the occupations and even everyday social categories like friend and colleague. We're going to look at what is the distribution of gender in that sense. And what we'll see is that there's actually evidence of pretty substantial overrepresentation of men. And this includes in categories like friend or neighbor, where what we mean by those categories is not something inherently gendered. It's actually supposed to equally apply to both genders. So seeing that there's a substantial overrepresentation of men in those categories is especially concerning. And you'll notice as well the way I define this is I focus on demographic associations because we actually expect that this will generalize to other kinds of bias, but what we'll focus on here is gender. So going on now to slide 8, I'm going to talk about methodology. I'm going to talk about our first part of the paper, which is the observational part. So if you go to slide 9, you'll see all the different data sets that we use, which we provide on my public GitHub page. You can see the link at the top for this specific project. And what I want to highlight here, because we won't have time to go into all the different data sets, I just want to say, as a part of this paper, we collected our own massive data set of images mapped to essentially all the social categories we could define. in the English language. This includes all occupations, but also those everyday categories I mentioned, like friend and neighbor and colleague. So in total, we got over 700,000 images mapped to 3,456 social categories from Google. And then we replicated this on Wikipedia, which has many fewer images, but we could get about over 20,000 images mapped to about 1,244 categories. We also look at images from IMDb and some other data sets, which I'll touch on very briefly later in the talk. But we also compare against textual data from a variety of platforms. So one of the main ways we compare images to text is through word embedding models, which I'll say a little bit about. But we also, look at these comparisons without word embedding models. So I'll talk a little bit about that. But what's nice about these word embedding models is they capture data across huge textual corpora. So they allow us to look at associations or meanings in huge bodies of text. So they're essentially tools for summarizing or aggregating huge amounts of textual data. And so we look at Google News, which is over 100 billion word tokens for the entire Google News corpus, and that was using the WordDevec model. And that data was collected in 2013 or 14, so also just to make sure our results work if we compare against more recent models. So we retrained our own WordDevec model on a sample of news published between 2021 and 2023, and everything replicates really beautifully. So that's nice to see. And we also, I'll touch on, we look at comparisons between Wikipedia images and these large language models trained on Wikipedia data, including the GLOVE model and the fast text model. We also compare against models that look at the web crawl, which is a random sample of the web. We also compare against GPT-3. So we won't have time to get into all this, but needless to say, we show that our results hold strongly regardless of the specific algorithm that we're using or the specific data set that they are trained on. So if you go to slide 10, you'll just see a quick summary of what the data collection pipeline looked like for Google, and this will give you a sense of how we did it otherwise. So we pulled all social categories from WordNet, which is this tool in computational linguistics that maps out the whole taxonomy of concepts in the English language. And this gave us, like I said, about 3,500 social categories. And then for each category, we would go to Google and automatically pull the top 100 Google images for each category. And we did this from a fresh IP, so spun up using a VPN in New York, so it had no history to it. And what's nice about this is because, as you might know, Google's image results are customized to somebody's search history and IP. So to control for that and make sure that wasn't driving our results, we spun up these fresh accounts. That also allowed us to replicate our results by using VPNs from different cities all around the world. Won't have time to go into detail, but our results do replicate if we do that. So we take these 100 images and then we extract all the faces from them using computer vision software. And then we upload that to a platform called Amazon's Mechanical Turk, where regular folks perform tasks to get paid. And in this case, the task was to look at a face and categorize its gender. So this is the perception of a person, right? And we looked for each image, we got 3 unique coders and then took the majority vote across them. And only about 2% of cases did people select the non-binary option. We included it, of course, because gender is a non-binary construct, but it only showed up in 2% of cases, and it makes the representation of gender more complicated because it becomes multidimensional. And so in future work, we're going to look into that. But for this purpose, we kept it binary. So what happened is if somebody used the non-binary label, we would remove that data and then hire a new mturker. And pretty much that just solved the problem because someone would come in and then select male or female. And then in all cases, we had a majority vote of either male or female for each face. And then using this data, we ran all kinds of controls. We controlled for the demographics of the coders. We controlled for how much different coders agreed with each other. And all of our results hold if we control for that. I'm happy to talk more about it, but want to move forward into the results. So this is how we analyzed the extent to which a category was associated with a particular gender and images. So imagine a female to male continuum. So if you go all the way to the left, -1, that's a category that's associated with 100% female faces in the search results. Go all the way to the right, 1, that's an image that is associated with 100% men. And if you get 50-50, that lands you at 0. So here's an example of where some of those categories fall. Now, to compare it against text, and this is on slide 12 now, what we use, and this is just a very quick summary of how this works. Happy to answer any questions if people have them. But basically, the innovation that has, set the stage for the large language model revolution is essentially you can look at correlations, co-occurrence patterns among words showing up in, say, the same sentence, but it's not always constrained to that. You can look at larger bodies. You look at which words co-occur together or which show up in similar situations, and then you can get this uh, representation in an embedding space, which is basically you give each word a position in some high dimensional space. Here I'm showing you just 2 to simplify, but imagine that these models have many hundred of these dimensions. And basically the magic of these models is words that are closer together in this space have similar meanings. And so because of this, you can run fairly simple calculations looking at how close words are in this space and get remarkably powerful inferences about meaning. So the famous result going back to the first word embedding models was something like if you take the position of king and then you subtract male and add female, that would actually give you the position for queen. So this is one of those smoking gun results showing how powerful these models could be. So here I'm showing you success and achieve are close and are far away from pizza. That might not be true for everybody. Maybe pizza for you is quite successful. For some of us, it certainly is. But this is just to give you a gist, right, of how this model works. Now, there was this really cool paper that came out in the American Sociological Review called The Geometry of Culture. And they showed how you could extract information about social features or stereotypes from within these embedding spaces. So they focused on class. So they would look at a cluster of words like poor, and poverty, and they would say, okay, we're going to call this like the lower socioeconomic class cluster. And then they would find the opposite cluster, like richer, affluence, and cluster those. And then basically what they would do is for any given category, look at which of these clusters is it closest to. And then they could create an identical dimension. A -1 would be closest to like you're at the center of the poor cluster, and 1 would mean you're at the center of the rich cluster. So we adapted this to studying gender using essentially the same technique. Just very quickly, it's totally robust if you use many different words on the polls. Here's just to give you the gist, but we show that it's not sensitive to this specific choice. But imagine you have the female cluster, the male cluster, and basically what it means for a category to say be closer to the female cluster means that that word co-occurs with the other words in that female cluster much more often, and through that shows up in much more similar context to the words of female. So it's being construed or conceptualized in a female way through this frequency of co-occurrence. And then similarly, if you flip that, the more that you go to the male side, the more that something is being associated with references to men. Now, this gave us an apples to apples comparison. I'm happy to talk more about what we had to do to set this up statistically. But basically, we could then line up where do categories fall on the image dimension and where do categories fall on the text dimension in terms of their gender associations. This gets us into the results. So now I'm going on to slide 15, and I'm going to focus on comparing the Google images to the Google News text results. So the first result, if you look at slide 16, is just verifying that the correlation, so the gender association for a given category, is highly correlated across images and text from Google. So this is good news, right? Because this means that, well, it's bad news for gender stereotypes, but good news for our measures, because it means that they're both picking up on similar structure. So we're really capturing this robust cultural phenomenon, right? Now, if you go to slide 17, this is our first hypothesis around how gendered is a category according to images and text. And this is where we see consistently that whatever gender a category is associated with, it is showing up stronger. It is dialed up in images compared to text. And what we're showing here is that is true not only for categories that are skewed male, but also for categories that are skewed female. So a male category might be plumber, but if a plumber is much more male in Google Images compared to what extent it's being referred to as male in the textual data. And similarly for female categories like nurse. We ran all kinds of robustness tests. I'm happy to elaborate. Basically, this holds if you control for which categories do humans judge to be male or female, and then you run this analysis, everything checks out really strongly. So if you go to slide 18, this is the second hypothesis, right, which is around a form of bias. So this is across all categories, what is the likelihood that you witness, say, a female-dominated versus a male-dominated category? So what I'm showing you here is just the raw distribution of gender associations across all of our categories, the 3,000 some odd categories, right? And what you see is that in the textual data, so the dotted line is 0. That's a category that's equally male and female associations. You see that there's a slight skew toward male representation. So when you're dealing with like 3,500 categories, that slight skew is statistically significant. But if you look at how that appears in the image data, the extent of that skew is much stronger. So this is what Cecil mentioned earlier in her intro, that this is where we see that the extent of that skew is roughly 4 times stronger, which is a major statistical increase. Now, you can see the tails of that distribution, so how close each one is to -101 is also stronger in images. So that's really why we're seeing this result, is the distributions are such that the extremes are stronger in the images and the skew is stronger in the images. And so that's really the statistical perspective we're taking. It's a kind of statistical bias that we're highlighting here. Now you might be wondering, okay, so you've compared images to text, and while texts do capture how people think, it's actually not often how the social world might be. The way we think can differ from the world. People aren't always able to be explicit about their beliefs. Say if you ask someone, do they have sexist beliefs? Many people will say no, even if behaviorally they do, or they might aspire not to, but say in their hiring patterns or promotion decisions nevertheless show gender bias. So the question is, how does our image and text data compare to, say, what people believe outside of how they talk, or what we see in like actual hiring patterns in census data? So that's what we're comparing against here. So the panel on the left in slide 19 is looking at people's actual judgments. So we recruited about 3,000 MTurkers who use that same -1 to 1 scale. We basically asked them, which gender do you most associate, say, with the category of nurse or carpenter or physicist? And then they would drag this slider, and that would give us a sense of the strength of their beliefs. And what we see is that both the images and text measures are highly correlated with people's beliefs, which is, again, really good, because what that indicates is that these measures are picking up something that's robust in the population. But importantly, we also see evidence for our hypothesis, which is that images are significantly more male. So this extent to which a category is represented, associated with men, is stronger in images compared to people's beliefs, and the extent to which categories are male is underestimated by the textual data. And this is, again, consistent with our predictions. Now, if you go to the census data, this is where we were able to map 685 occupations from the US Census to our WordNet database of categories. And we can look, okay, across all these occupations, this is the 2019-2020 census data. It does replicate if you look at different census years, but this is the one that was closest to when we collected our image data. If you look across all these occupations, you say, okay, what is the average gender skew? Is it female or male? According to text. And what you see is no gender skew. So according to text, any occupation in our data set is equally likely to be skewed male or female. Now, if you look at the census data, this is the ground truth. What is the fraction of men or women in these occupations? You see that there actually is bias towards male representation in this sample of the census, which is, a fairly large sample, 685 occupations. Now we look at, what do the images tell us in terms of male or female representation for those same occupations? And what you see is that this male skew is intensified in images. So occupations are much more likely to appear as predominantly male in images compared not only to text but also the census. So this is another way of showing that our results are consistent when we benchmark, when we compare against what you could consider the quote unquote ground truth. So now on slide 20, I just want to quickly say, we also replicate this looking at Wikipedia data. And actually, it just so happens today that the Wikipedia Research Foundation wrote an article about our piece, reviewing it, and it was generally favorable and showing that it was consistent with what they've seen. And we're proud to say that our results actually spurred someone to, an editor on Wikipedia, to add an image of a woman to the Wikipedia page for mechanics, which was only showing men, and actually led to a little story about how mechanics were actually predominantly female during the Second World War. So very a small win, but a really inspiring form of impact from our research. So if you go to slide 21, what you'll basically see is this really robust replication comparing images from Wikipedia to the textual representation of gender from these Wikipedia articles. And so a plot on your left is showing the strength of gender association, and we see that significantly. But if you look at the right panel, this is just the probability of a category skewing male. And what you see is that almost 80% of them are predominantly male according to images. And we look at all these different text models trained on Wikipedia, and what you're seeing here is models of different dimensionality. We don't have to get into the details of that, but basically you might think to yourself, what if text is just more subtle? What if it just captures more information, right? Well, one way to think about that is through the dimensionality of a model. So you can reduce the dimensionality, which means the model is going to have fuzzier, or it's going to struggle to differentiate categories more than if you give it more dimensions to do that. And what we see is reducing the dimensionality of these models has no effect on this gender bias. They're all slightly skewed male, but still way further below what we see in the image data. If you go to slide 22, basically this is another replication on Wikipedia and IMDb, but what's important here is, as mentioned before, all the gender data in the images relied on people's judgments, right? So that was in some ways a study of human psychology, because we don't know what the actual gender of the people is, and that's super hard to get when you're just getting this data online. But one way you can do that is by studying celebrities. So this is a data set of over 500,000 images where they are mapped to over 70,000 celebrities, where you have their public bio pages and you can know their self-identified gender and their age. And so it's a specific setting, it's only about celebrities, so there's only so much we can learn from that. But it's a setting where we can test, do our hypotheses hold, where we don't rely on these human judgments or, say, machine learning algorithms, because all of our other results do replicate. If we look at the main ones replicate if we use machine learning. But here we don't have to do that. We just know the actual gender. And so on slide 23, what we see is our results actually replicate very nicely. So if you look at census data on who gets to be a celebrity, so we're looking at the most macro category here, you see a very slight skew towards male representation, but generally equal representation of men and women in celebrity. Now, if you look at what does Wikipedia textual information tell us about the gender skew, the gender identity of, say, celebrity as a category, you see it's slightly skewed towards women in both the facts text and the glove model. Now, what do the images tell us? Interestingly, we see a reverse. According to images, celebrities are actually predominantly male. So who are the people that are getting the fame and getting the attention, the most visited IMDb and Wikipedia celebrity pages? We see that they are predominantly male. And the overall strength of that gender association is significantly higher in both IMDb and Wikipedia. So in IMDb, about 60% of the faces showing up are male. And when you're dealing with almost 500,000 faces, the statistical significance here is off the charts. And then if you look at Wikipedia, again, we're getting roughly around 80% of the celebrity faces that are showing up are male. So this is a huge bias towards male representation in our categories for who's famous in our concrete and fictional worlds. So next on slide 24, I want to pivot and basically ask what are the psychological consequences of gender bias in online images? Like, does this actually matter? Or is it just a flash in the pan or a drop in the bucket? When people are exposed to these images, does it actually impact their beliefs? This is where we designed an experiment. So if you go to slide 26, this gives you a quick gist of our experiment, right? So we looked at 54 occupations split between science and the liberal arts. So you might say like doctor or painter. And we basically recruited folks to actually go to Google and search for descriptions of these categories and then upload those descriptions. And then after they would upload those descriptions, they would use that same slider from -1 female to 1 male to tell us which gender do they most associate with this occupation. Now, if you go to slide 27, you'll see the general conditions we randomized people into. So we recruited from Prolific's nationally representative US sample, and they were randomized either to a text condition where they were sent one version of the text condition was they were sent to Google News and they would search doctor and they would have to actually find a textual description of a doctor, and they were only allowed to upload this textual description. Now, in the supplementary appendix, we also show that these results don't change if you send people in the text condition to the standard google.com search bar. It all holds. Now, 1/3 of the people were also sent to the image condition. So now they're sent to Google Images, given the same category, doctor, and now they have to choose an image. And we let them choose whichever image they thought was a good representation. And then they would upload that. Now, in the control condition, this is important because people were basically asked to search for either textual or image descriptions, but they were asked to search for random categories like Apple or guitar. These random distractor categories that had nothing to do with the occupations that they then evaluated. And so you'd say, go search an image of an apple, but then after you'd be given an occupation like, painter or doctor, and say, which gender do you most associate with? So essentially, in the control condition, we severed the connection between the content that they searched for and browsed and the occupations they then evaluated in terms of the gender. Now, our main outcome that was most robust and that followed most directly from theory was the strength of their gender bias using that slider. But we also looked at their implicit bias. Now, we did so using what's called an implicit association task. And implicit bias is essentially, it's attempting to get around the problem, like I mentioned before, is if you ask people, are you a racist or are you a sexist? People will typically say no because it's more socially desirable. People recognize that it's a bad thing to be viewed that way. But if you look at their behavior, you can still find evidence of some of these biases, which they may or may not actually be aware of. And so the implicit association task is one way to try to get at that. So basically, you're given a set of categories, and you just have to click which of the following do you associate them with. So say it's physics, you have to click left or right. You associate it with women or men or liberal arts and science. I don't have time to go into all the details. It breaks down into various ways, but the main thing to keep in mind here is what they're looking at is whether someone is faster at associating something like physics with men than physics with women, and vice versa for, say, categories in the liberal arts. And in this case, we were looking at whether there's a bias towards associating men with the sciences and women with the liberal arts. And this has been a stereotype that is still widespread in terms of, say, college majors that women and men choose, hiring patterns, and even shows up in early childhood beliefs in education. Now, I just want to say, I personally am not a huge fan of the implicit association task. It's known to have a lot of problems. It varies a lot based on, if you repeat measurements. So we view this as more suggestive. Interest and outcome of interest is that explicit gender. We see is just sort of like a robustness test. This is looking at what would need to be the case for our theory to be evaluated. So remember, one of our main arguments was that gender bias was going to be more frequent in images than text in terms of the extent to which a category is gendered. So what we did is we actually coded the gender of the descriptions uploaded by people. So in the text condition, if someone uploaded a description of a doctor that mentioned a man, or used to say the doctor did this because he thought it was the appropriate test, that would be referring to the doctor as a male, versus an image where we actually had people code the gender of the picture of the doctor using the same techniques as before. And what we can see is there was gendered images in both, gendered descriptions in both conditions, but the overall strength, the overall frequency in which a gendered description was uploaded was way higher in the image condition. So this was suggesting in some ways that people in the image condition were way more likely to be exposed to or be primed to be thinking about gender and the representation of these categories. So then if we go to slide 31, you'll see this is our outcome variable of interest. So what was the actual gender, the strength at which they dragged that slider to associate a category with either men or women? And what we see is there's essentially no difference between the control condition and the text condition. So this is the exposure to descriptions of these categories of text didn't activate or reinforce gender associations above and beyond people who saw content that was irrelevant to the categories. However, if we look at the image condition, what we can see is that the strength of the gender association, so the extent to which they associated a given occupation with men or women, was much higher, significantly higher than both the image and the text condition. And in one case that we report in the paper is if you look at, say, the gender association of the occupation for a model, like a fashion model, you see that it was almost twice as high in the image condition compared to those in the text condition. Now, if you go to the next slide, you'll see some really nice internal relationships which show the mechanics in some ways of what's happening. So on the left panel, what you see on the horizontal axis is the average gender bias in people's content that they associated for a given occupation. And what you see on the vertical axis is the average gender association and participants' responses along that -1 to 1 scale. And what you see is this really tight correlation. So for cases where people uploaded images of a lot more men, that actually correlated very strongly with male associations on the slider. So there's this really tight relationship between the content they're uploading and their use of that slider. Now, this holds in both the text and the image condition, but what you can see is that the extent to which there's alignment between the descriptions uploaded and people's responses is way tighter in the images compared to text. Now, what you see on the right panel is essentially that exact same finding, except now we're not looking at male or female. We're just looking at, on average, the strength. And you see that that same correlation holds. So the stronger the association and the content people uploaded, the stronger their biases using that slider. Now, what I want to talk about in slide 33 really quickly is this is the closest we can get to a psychological argument here, because as I mentioned before, one of our arguments was around frequency, right? That gender bias would be more frequent in images compared to text. But we also had this psychological argument, which is that when a given image or textual description represents a particular gender in association with the category, we think the images will be stronger at activating this in people's beliefs. That's what this looks at here. So this is looking at our experimental data, but we're only going to compare images and text that present a particular gender looking at an occupation. So we then look at, for those who say were exposed to a male association in text versus those who were associated with a male image of an occupation, what was the strength of the gender association they indicated on the slider after that exposure? And we see that it's significantly higher in the images compared to text. And this holds if we hold constant the actual occupation, so it's not driven by particular occupations. These results even hold if we control for the gender of participants in the experiment. So all of this is this really robust fact of this difference in priming, the intensity with which images activate these biased representations compared to text. Now, slide 34 shows our results looking at the IAT, and this is where our results are a bit weaker. So we actually don't observe a significant difference between, so first of all, let me say, in all conditions, there was a significant implicit bias towards associating men with science and women with liberal arts. So that's, upsetting. We get this very clear measure of this stereotype. Now, like I said, our results are a little bit noisier here. The IAT is noisy. And so we actually don't see a significant difference in the strength of this implicit bias in the image compared to the text condition. But what you can see from the direction here, the ordering, is actually only the images showed a significantly higher implicit bias compared to the control condition. So we view this as suggestive that this experiment, this exposure to images activated, whether it's explicit or implicit is an open question, but they activated these gender biases more strongly than those in the text condition. What you see on slide 35 is that actually people's explicit gender associations using that slider, it's in fact very correlated with their implicit bias in the task. So we view these as somehow inherently related and interesting questions for future research. Now, just in the interest of time, I'm going to go quickly, but if you look at the following slide, this is basically just showing that we could actually predict what people did in the experiment using the data we collected on our own. So if you look at the gender biases in the huge Google image sample that we collected, that strongly predicted gender biases in the content that people uploaded in our experiment and strongly predicted gender biases in their beliefs. So I find this particularly striking because in some ways it means we could just use Google data to learn about, in some ways, collective patterns of psychology, which I find fascinating. And the second version of this looks at the text data where we see the same thing. So the model of gender associations in our word embedding model of Google News, again, can predict quite well the content that people are uploading and also their beliefs as reported using that slider. So in conclusion, first off, we show that the gender gap is larger, substantially larger in online images than online text. This is concerning in light of this broad cultural trend toward image-based communication, image-based search, and away from textual communication. We also find that images are more powerful than text at reinforcing gender bias in people's beliefs. And again, we see that this is surprising and alarming because it's not simply that they're more powerful, but again, we see that its images are consistently more skewed towards male representation and also intensified stereotypes. So we have stronger statistical bias, and it is landing stronger. It's actually being communicated more forcefully through images compared to text. And what this suggests is that when we see these narratives of progress towards gender equality coming out of scientific literature and a lot of discourse, we think that we should evaluate them with caution because essentially there are ways in which cultural changes in text may not be representative of what is going on more broadly in culture. So in text, as we mentioned, there are these sort of cultural innovations people have developed, like gender neutral terminology or the ability to just remove gendered information. That is much harder in images. So how do you show you a concrete image of a doctor without providing gendered information, for instance, is a particularly tricky problem. Because if I say, show you an image of an amorphous blob that has what you could say the effort is to have zero gendered information, you might respond to that and say, well, that's not an image of a doctor. I want to see an image of a doctor, right? And this gets us to this fact that actually knowing what would be an equitable or balanced representation in images and text is fundamentally different. So what we see is in the case of Gemini, right, that Cecil mentioned earlier, they are sort of falling on the opposite end of extremism. So now you're searching for, say, an image of the Canadian Prime Minister, and you're getting images of, African American and Chinese people, which, that's perhaps great aspirationally, but that's not what people had in mind when they were searching for a factually accurate representation of Justin Trudeau. And so what we get is this question, which is, where do we want some of these, like what would fairness be defined in the case of images? And our intuition is something like a distribution. You want equal numbers of, say, men and women, equal numbers of different races, but that isn't easy to implement when we start to get cases like the Canadian Prime Minister, or even in the case of Gemini, one of the other controversial cases was people searched for images of, say, Nazis at a march, and they were showing images of, say, African Americans and Chinese people, and then people online were very upset because they're like, we were not there. We definitely don't want to be shown as a part of this situation. And so where do we go from here? Well, we certainly have evidence that's bubbling up in the research that part of the reason why these models have gender bias in the first place, these text to image generating AI models, is because they're trained on data sets like the ones that we collected. So they're trained on Google and Wikipedia image data sets. So the CEO of Midjourney, for instance, said on Twitter that essentially once you get to millions and millions of images, there's essentially no well-defined corpus of that for people other than just what you can scrape from online sources. So there's pretty good evidence that these models, at least in part, are trained on image data sets that are publicly available, like the kind that we've collected. And I think for our research doesn't directly indicate any technical solutions to this problem. We think that this will inevitably involve conversations both from engineers, civil society, researchers, public opinion. All of that is going to factor in. And really, it boils down to a really hard philosophical question, which is what do we want our algorithms to do for us? So typically when I present these results, and I presented them to a handful of Google engineers, I will get the response like the following, like, oh, if you search into Google for nurse and you get a bunch of women, isn't that just Google doing its job? Because, more nurses are women in the quote unquote real world, and Google's just echoing back that fact, right? Now, the problem is that you can say, okay, sure, maybe we want Google just to represent quote unquote reality, but what if that reality is itself the way it is because of patterns of bias, say who gets hired, or when kids are growing up, who gets encouraged to be nurses in terms of stereotypes? If that is true, which there's a lot of evidence that it is, then it's kind of a cop out to say we just want Google to show reality, because essentially what that means is saying we want Google to present something as truth, whereas while it's a very highly biased representation of truth. And here's maybe one way to get at that intuition. So if you were to search into Google, define nurse, you'll get something like the following: a person with specialized training in taking care of the sick, most often in the hospital, something like that, right? Now, if you searched into Google for a definition of nurse and saw a definition that said a woman with this kind of training to take care of a nurse, to take care of the sick in the hospital, you would think that because it mentioned woman, that definition was biased, right? That there was something factually inaccurate, because what we mean by nurse is something more abstract. It's like it happens to be the case that in this time in our society, maybe for a variety of biased reasons, more women are nurses, but there's nothing inherently defined in a nurse that makes it a female category. But if you search in Google Images for nurse, the intuition that you get from that engineer type is that actually it's because they're showing you women that those descriptions are correct. But this is where we start to get to that kind of paradox, that these problems actually need to be evaluated differently in images. And I think what the Gemini situation reveals is that these tech companies, and perhaps as a society, we just really don't know how to solve this problem right now. We need to think differently when looking at text compared to images. And I have some intuitions for how to do that, and our ongoing work will hopefully help us make progress in that direction. But I'll leave this at that, because I know this has been quite a lot of content to digest. So on the final slide, you'll see, I'd just really like to thank you all for your time, for inviting me here. You've all been really patient listeners. If you want to keep in touch after this, follow my content, engage in further discourse, you can follow me on Twitter here. Otherwise, I really look forward to opening this up to discussion.
Yeah, thank you so much, Douglas. So yeah, we are opening the floor for discussion, and for those who had spoken on the room chat, I sent you an invite so that you can probably ask a question or have follow up with your question with our guest speaker. And yeah, this is like a very timely guesting of Dr. Douglas Guilbeault here in Quantum Photonics, because this is the International Women's Month. And also, we had this Google controversy as to being too woke, which has hit in the past few days, media as well. And up to now, they are asking, where is Sundar Pichai to address this? So, Um, we'd like to inform everyone that please feel free to raise your hand if you wanted to ask a question here or yeah, make a comment. So I would like to introduce our guest speaker. I forgot to introduce our guest speaker at the opening of this event. So Dr. Douglas Guilbeault is an assistant professor in the management of organizations group at the Haas School of Business in UC Berkeley. So he studies how communication networks underlie the production and diffusion of cultural content such as linguistic categories and social norms. This investigation extends to how communication dynamics are shaped by various sources of influence such as organizational culture, political messaging, and the design of social media platforms. His work on these topics has appeared on a number of top journals, including Nature Communications, the Proceedings of National Academy of Sciences and Management Science, as well as in popular news outlets such as The Atlantic, Wired, and the Harvard Business Review. Guilbeault's work has received top research awards from the International Conference on Computational Social Science, the Cognitive Science Society, and the International Communication Association. Guilbeault also worked as a consultant on social media policy and people analytics for leading tech companies, for example, Google and Facebook. And his current research is funded by Facebook and the NIH. So his expertise and research interests are in computational sociology, collective intelligence, culture and cognition, social contagion, categorization, and social media policy. So I had posted a link on his bio here at the room chat. Please feel free to check out more information from Douglas on his selected papers and publication, his positions, honors and awards, research grants, and yeah, stories about him in the news. So yeah, I would just like to mention that I think there was a great presentation, Douglas, because basically, here in Clubhouse, trying to address the mainstream, we had a previous club like 1 million women in power, trying to address and also ask questions about what's happening about gender equality in so many years. That it has been advocated and what's happening now. And in some of the discussions that we have, and I mean, these are not people in the academe whom I was just, trying to talk to, but, just ordinary people, maybe representing different jobs and also countries and also, yeah, the cultures that they had been on. And we had, I think, in one of the discussions, I was saying that this gender bias is, of course, has been in advocacy and also conversations and also policy making for quite some time now. But if we try, since you were speaking about the stickiness of an image there, so for me, for instance, and maybe a lot of people in science, they would go back to the Solvay Conference of 1927, wherein you see that only Marie Curie was in a group of maybe about 30 or 40 scientists, so most of them had won a Nobel Prize, and she was the only woman. And it also brings me back to Emmy Noether, who is a very great mathematician and whose work has influenced a lot of work in physics and also has influenced the work of Einstein in his theory of relativity. So you would see that there was only one woman there in particular instances, but they have made a great dent in the world and also a great dent in their particular field, like, a physicist among physicists or a mathematician of mathematicians. So that is a very important image for me. But on the other hand, for those even men that a lot of people are trying to blame for gender bias, for instance, you would note that you will be asking a question: who has raised these men? And, in general, of course, what is happening in the world is that in general, women are raising children. And when you start to raise children, even from the time that maybe there is some conception or you're preparing for the child to be born, there is already bias in how women also try to select colors for the kids. So, yeah, the bias starts there, like pink for girls and also blue for boys. And in the selection of toys, generally also society has a predisposed concept on how girls are supposed to be having toys, and that has some kind of entrainment, that has some kind of stickiness alone in the minds of anyone, whatever his gender is. So I think this is a very interesting observation to make. So yeah, and also your comment on how long does the stickiness last, for example, even in words itself and not even in images. So I noticed that even toy makers have changed a bit, like even Barbie and also Lego has changed this. But I don't know, just like what you said, when this will problem will be solved. But I was just this is just a comment that I would like, not a question, but I would like to say that maybe in the future it would be very interesting to look at, like we categorize our study based on the culture, because there it's very significant, and also on the generation of the people that we try to get as samples, because probably um, every generation criticizes the next generation. But for somebody who was born in the Gen X and probably uh, born on the Gen Z, if you talk to children, maybe about 3 to 7 years old, they will have different representations, because there are changes actually, although we think that these changes are not very significant. So anyway, it's very long, but I would like to ask you, do you have any future studies that will also build on top of this, I think, very important study that you are having?
Thank you. Yeah, I mean, those are really fascinating and relevant comments. So the first thing I want to say is that there are ways in which, so there's some really good research showing that categories like gender are actually much more foundational to our thinking than we might realize. So there's, very explicit forms of gender stereotypes, but there's also the ways in which it underlies a lot of our thinking. And we have one paper in Cognition a couple of years ago which shows this lurking in image data in perhaps a surprising way. So the paper is called Color Associations in Abstract Semantic Domains. But basically, we collected a bunch of Google images associated with a wide variety of academic disciplines. And we looked at academic disciplines that, I don't like this terminology, but just to get the gist of it, we looked at, say, the soft sciences versus the hard sciences. And these are typically where you would see gender bias in terms of our stereotypes of, men are going to fall into the, mathematics and the hard sort of engineering sciences, and women are more likely to fall in sort of the arts and humanities and, say, the social sciences. If you look at the colors that are just showing up in Google images relating to these disciplines, you get this continuum of like warm to cool colors. So the more that you're closer to the soft sciences, you see reds, you see pinks, you see oranges, which are bright and warm and evoke like passion and these sorts of things. Whereas if you get to the hard sciences like physics, math, and computer science, you get blues, purples, and blacks, which are like cold. And this actually picks up in blues, of course, blues. This picks up on some of the stereotypical gender associations. And this is just lurking in the image data at a large scale, because Google images, of course, are just mirroring back what millions and millions of people are searching. So we thought that that was really fascinating. And this really opens the door towards, I mean, what, as a scientist, I'm most interested in is thinking about how we can use this data online to learn about ourselves and our culture as a kind of like cultural analytics or cultural x-ray into beliefs that are lurking in our population that we might not be fully aware of. And so one that we have a paper that we're very excited about right now that is an extension of this is actually looking at age-related biases. So basically the invisibility of older women. So there's a bias towards representing women as younger and men as older. Now, this is a bias that very few people have been aware of in terms of, say, building these AI models, but we all sort of have anecdotal experiences, right? So there's evidence, say, if you look at the workplace, uh, adult women are way more likely to be referred to as girls than adult men are to be referred to as boys in the workplace. So there are these patterns, but we basically will be providing, to our knowledge, the first massive scale documentation of this bias across all different kinds of modalities, images, texts, and videos. And so that's one next step. But of course, we're very interested in all the different kinds of biases that we can model, understand through our data. We hope that this is actually the start of creating productive conversations in people about not only the biases in our culture, the beliefs in our culture, but also how these algorithms are mediating that and reinforcing it and spreading it. And then how we can intervene. What do we want out of our algorithms? Do we want them to show us reality, even if that reality is biased? Do we want them to intervene and editorialize and show us content that is aspirational? And I think what something like Gemini is showing is maybe we want that, but we don't want it to that extent, right? So where do we actually want this balance, this trade-off between reality and something like progressive inclusion to inspire those to say seek membership in categories that go against the stereotype because we need that for a lot of innovation and positive change. So that's a really hard question that we're hoping our research kickstarts for all of us.
Yeah,
Super. Oh,
thank you so much, Douglas. So, yeah, I would like to pass the mic to the speakers here. And yeah, I think Sam should be next, although Nas was here earlier, but he went off the stage. So I had already pegged Sam to ask his important questions. So, Sam, mic to you.
thanks, Sue. Douglas, I think that was a great presentation, by the way, and I really liked how you used the model and you explained exactly how the data set was being applied and what
Mm,
categories you used. And I think you raise a very fair point, right? And one of the questions I wanted to ask you is, first of all, the bias is a very important part, but can we actually be unbiased as human beings, like at a very
mm.
philosophical or scientific level? Is are we even capable of removing bias from our nature?
That is a very interesting question. I
Because
will say I'll start by saying people can learn critical reasoning skills that get them out of logical biases or weaknesses of intuition. So people can improve in their ability to solve problems. And I think all of us know what that's like if you compare, say, your problem solving abilities when you were a child and teenager to how you think now. We've learned lots of skills. And so there are certainly domains where we can override certain cognitive biases. Now, something like gender stereotypes, there are questions around because those are particularly deep, they can be particularly steeped in culture, they can be hard to see. I believe that people can, and there is research showing that people might be, more open-minded than they might realize when presented content in particular ways. But I think this is where I would raise the question of maybe this is where our algorithms might be able to help us. Now it opens a question because humans have never had algorithms like that in history. So maybe there's an opportunity here if our algorithms can help us guide us towards what Steven Pinker might call the better angels of our nature. But of course, the risk is how do we know they're going to do that and not make things worse? And there's a lot more to say on that. But I would say even if we assume some of these biases are deeply entrenched from our say culture, biological and cultural evolution, I would just say we have tools that we've never had before that might be able to help us out of this problem. But then we need to think very carefully about how to do that.
and also for this research, like hypothetically, for me to identify that as a bias, as I said in text, like was there any comparison to what was the real state? Because I understand what you're saying, right? Let's say there were more physicists who were men in the past, and that has created a lot of images of men as physicists. And now those images are in a way superimposing on people that only men can be physicists, whereas in modern
Mm,
society, women have the actual means to have that same, intellectual ability to grasp that subject, right? And so you create this loop in a way where a reality, in a way, is now confirming people of what should be, but the society is changing, and that change is not incorporated in those images. Yes.
yeah, that's right. There are so. our own data set isn't looking at over like changes in images over time, though we are working on that. We think that's very important. But our intuition definitely is what you're picking up on, which is that in some ways the cultural change is lagging behind in images. And I'll give you an example of, say, why that might be the case in Wikipedia. It turns out that because Wikipedia can only use images that are approved for public intellectual property, those actually tend to be older images because the newer images, it's harder to verify and guarantee that they've been approved for, popular intellectual property and Creative Commons, which then biases towards older images. You also see in the case of, say, IMDb, of celebrities, where historically, like if we go back to the 50s, many more men were celebrities because men just got to have these high-paying, famous jobs and or prestigious jobs. So we also know, men would actually play the roles of women at that time. And so that's going to be showing up historically in terms of the movies being depicted and the frequency of men. Now, that's not the only reason, right? It's not just historical. There's also the fact that if we look at male politicians today, male CEOs, it's not just skewed towards male representation, but they get covered much more frequently in the news media. So it becomes a self reinforcing system. And I think that's, to your point, the question of how is this system set up to exaggerate or oversimplify or intensify our biases. And I think, of course, our studies about gender, but I think some of the mechanisms we're talking about around images amplifying bias is a much more broader aspect of our new media landscape that we're trying to highlight. Happy to say more about that, but I think the implications are even go well beyond gender to a wide variety of topics.
See, what I'm curious about is I think there is an inherent bias in me. Let's say my mother is a doctor. She's a female, right? And let's say even in the real world, there is an actual representation of men who are more doctors. When I look at doctors, because my mother is a doctor and I see her regularly, there is an inherent bias that because in the initial conversation, you made this point that images play a huge role. And I think even when you look at someone, there are images going through the flash of your, back of your head, trying to associate things you already know or people you already know with things you're seeing. And so I think there is an inherent bias in me when I have someone, let's say a mother or a father as a doctor, and when I'm trying to look up doctors, that bias kind of, yeah, I think that's a very individual level. And I don't think if I can get away from it because that's my exposure to reality. Does that make sense? Like,
So there, yeah, so that contributes. People's experiences, they definitely are anchored or skewed towards their experiences and their understanding of these categories. But there is research that people can learn to expand their categories if they expand their social networks, right? So one way to look at that is, say, in political views. If you grew up in a small town where everyone's Republican or everyone's Democrat, you might have a sense like, oh, most people think this way or most people have this belief. But then typically what you can see is, people say go to university or move to a big city, and they are surprised to meet all kinds of people who think differently than them. And that complicates, it forces them to have a broader, more expansive view of, say, what Americans think in a more abstract level. And there's research showing that in the case of gender or race stereotypes, where as people are exposed to a wider variety of people from different genders, different races, different sexual orientations, they start to develop more generalized understandings of people. Now, it's not guaranteed. This is where it gets more complicated. I'm happy to elaborate, but that's not guaranteed to lead them to have less bias. Sometimes there's a kind of backlash effect, and for a variety of reasons, people are resistant to having an accepting view. But there's also quite a lot of people who approach that diversity with an accepting view, and what they do is they actually deepen their concept of what is a person, what is a gender. So if, say, you've never met someone who identifies as gay, you might have a particular stereotype of what a gay man is like. But then when you meet a bunch of gay men, you discover that some of those stereotypes really aren't representative. There's all kinds of people. They're like a huge variety of different types of masculinity of people. There are people who are extremely macho and also identify as gay men, right? So there's all kinds of counter examples to the stereotype. And for those who are accepting, what they'll do is they'll respond to that and be like, oh, my beliefs were wrong. My assumptions were wrong, right? And so that's where it becomes almost like a critical thinking type question of who are the people who will confront these counter examples and actually update their beliefs versus those who will double down. And that's where there's an interesting there's a lot more to say there, but I hope that gives you some interesting things to think about.
Yeah, definitely. I think that was a great presentation, by the way, and thanks for sharing it.
Thank you so much. Really,
Yeah,
really
thank you,
appreciate your interest.
thank you, Sam. So we'll now go to Nas, who is here on stage. Nas, I'd like to give the mic to you.
Yeah, thank you, Cecile. Thank you, Douglas, and greetings from the Bay Area, from Palo Alto, your neighborhood. I have two questions. Number one, I understand the bias for imaging of male, female, gender, and so forth. Are there any more advanced, more sophisticated technological application for this? For example, for medical reasons, uh, if you do imaging of cancer cells or other form of medical treatment, is the technology sophisticated enough to recognize this precise imaging? Because that would be huge breakthrough in diagnostic and therapeutic approach if the technology is capable. And the other thing is, speaking of gender bias, since many companies now, most companies, at least here in the Silicon Valley area, as you know, they use AI for HR, and soon HR probably will be replaced by uh, AI. How, and since you are in business school, uh, that would have a serious ramifications in the hiring process uh, because
Yeah, that's
it's
exactly right. Yeah.
yeah. Those are the 2 points. Are there other scientific applications for the technology now? And then the racial uh, bias in, I'm not so sure the word racial is the right word, bias in image recognitions for hiring
Yeah,
purposes.
yeah, these are excellent questions. The short answer is yes to both, absolutely. So with the first one, there actually have been some papers showing that there's algorithmic bias in diagnosis, and that is as a function of, say, race and gender, and that this is actually partly a function of biases in the training data for these algorithms. So, for example, there's known biases in pain scale. So, when men say they're experiencing a certain amount of pain, or women, uh, doctors are biased towards, say, discounting the pain that women report because there's this stereotype that like women are more emotional and complain more, which is totally false, especially in this medical context, and has nothing to do with their pain and can lead towards these erred judgments. I actually have a paper from 2021 which showed these kinds of biases, race and gender biases in, say, diagnosing cardiovascular disease, looking at spectrograms and other issues, showing that the doctors were more likely to make errors when diagnosing women, uh, black women in particular, but that we could actually address those biases through collective intelligence by getting doctors to communicate with those who are less biased and learn from them. So I'm happy to follow up afterwards with that, but the short answer is there is actually a growing body of research showing that these kinds of biases do exist in the data sets because of the images that are collected or the doctor's judgments that are collected, and those then get reproduced in the AIs that are learning from that. And it's an enormous problem because, when you have an AI applied at scale in something like the medical system, the inefficiencies of misdiagnosis are extremely costly. Like we're talking millions or potentially billions of dollars being lost because someone was given a misdiagnosis and then had to come back for another hospital visit. So even if we get to something like, oh, it's a very slight difference, like they're 1% more likely to have a misdiagnosis, when you're dealing with massive populations, that actually is like a huge inefficiency that not only is like bad for the medical system, but also reproduces inequalities in terms of who's most likely to be negatively impacted. Often it's the people who don't even have the same amount of money to cover or the lack of insurance. So it becomes this really horrible problem. Happy to say more about that. But to your other question, that's another context in where these problems are severe. And so there's a documentary that HBO had called Persona, which I recommend. And basically, it's about the use of personality tests in hiring. So let's put aside the question of whether personality tests are actually science or pseudoscience. It's a very interesting question. But given that they're highly speculative at best, it's problematic that these HR firms are, because it's not just that they're using personality tests to determine who's a good fit, but they're using computer vision algorithms that will look at someone's like video recorded interview and then score them in terms of say their personality and their fit or their performance, which is just bonkers. Not only because the literature showing to what extent you can predict somebody's performance based on an interview is itself very limited and challenging. But then the other layer is, can you actually predict that simply by having a computer vision algorithm that looks at someone's facial movements? And that's where it's extremely dubious because, we know that there's actually a huge body of literature showing this variation in people's facial expressions of different emotions. People with personalities can have very different ways of expressing their emotions, even if they have similar responses on these personalities. And it could be the case that if we assume particular personalities are a good or bad fit, you could actually get all kinds of problems in your organizations, like people that are too similar, or people who don't cooperate well together. And so becomes this machine for reproducing bad judgments, bad hiring practices. And the class I teach at Berkeley, one of the classes is called People Analytics, and this is precisely the kind of thing we talk about, people algorithmic bias. And so our results are highly relevant to that because there's, of course, huge gender biases in the images and videos associated with these computer vision algorithms. And there are going to be biases in terms of what kinds of personalities or what kinds of like leadership aptitudes or leadership styles that these computer vision algorithms map someone onto based on, say, a 20-minute recording of themselves speaking of video. So there's a lot more work to be done. It's an extremely important set of problems. So thank you so much for that excellent question.
Yeah, I will follow up and read your articles at Berkeley for sure. Thank you.
Thank you very much.
Yeah, thank you, Nas and yeah, Douglas. So, Bob, I would like to ask you if you have seen some questions or comments here at the room chat, which you would like to read. But in the meantime, yeah, okay. Bob, I pass the mic to you.
All right, thank you, Cecile. I'm very impressed by your selection of data sources. Did you leave one out that you would like to have included?
Oh, that's a great question. So I would say the more data, the better. So I would love to say, for example, to have studied TikTok, or to have studied LinkedIn. But there's a lot of platforms like those that are very hard to scrape, very hard to get data on. So to some extent, we studied Google and Wikipedia because, to their credit, it's much easier to access their data sets publicly. But in some ways, the juiciest context would be, the TikToks and the Instagrams and the Snapchats, but they, by design, make it very hard for people to scrape that data. So if anyone knows how to do that better, I'm all ears because we would learn a lot by being able to do that. And we're working on it on our end. It's just going to take more time.
Bob, are there any other questions on the room chat?
The room chat has basically been a conversation between a couple of folks, so no relevant exact questions.
All right, thank you. So, while you were having this conversation here, Dog, I just noticed my Facebook account. In Facebook, I have almost now 46,000 followers, and my reach is 23 million. And most of the topics that I post about is about artificial intelligence, physics, math, neuroscience, biotech, exponential technologies, and immersive technologies. So it just made me think without any bias also at all that when you look at the demography of my followers is that I'm a female, but my followers are 80% male. And the number one followers that I have are millennials. Number two is Gen Z, and then Gen X, and of course there are even Gen A. So yeah, how do you think about that? I just thought about that coincidentally as we try to bring this topic up in our forum now, and I never intended to target um, any group or generation or any gender when I post that, but yeah, it just naturally happened. And I was thinking, how relevant is also your study based upon what is actually happening to me? So this is, and of course, my audience is like people worldwide. So this is like an example of something which just emerged. Can you say something about this?
Yeah, this is very interesting. I mean, I think looking into generational differences is going to be a fascinating area for future research. There is evidence that some of these biases are still playing out. So certainly, if you look at say Gen Zs and newer generations, there's a lot more openness towards say gender fluidity, non-binary genders, all different kinds of gender-based and sexual identifications. Nevertheless, you also see patterns like who gets to be an influencer that are heavily skewed towards gender stereotyped identity. So it's like, women who are cooking are hugely like successful in terms of their influencer status, and that's partly a highly stereotyped identity. Um, Whereas male athletes get a lot more attention on these platforms. There's also to the ongoing project I have around age, you see, I think very concerning trends where you know girls are trying to become influencers at a very young age and are developing extremely intensive beauty routines, and some of them are actually seeking, you know, whether it be plastic surgery or other things to try to make themselves, more successful as influencers. And this trend is extremely concerning, in my opinion, and it stems from these gender stereotypes and how they are putting pressure on these market dynamics, which are primarily about marketing personal image and marketing personalities. So um, basically, it's an extremely important question, and I hope to provide more insight into that with our future research.
Yeah, thank you. Um, we have Aaron here on stage. I just want to ask you, Dog, because I think some people would like to speak. However, we want to give an opportunity to everyone who came here to be able to speak. So I'd like to ask you, how much more time do you have for us?
Uh, for now, I mean, uh, I may have to go soon. I'm waiting on another meeting, but that person may or may not arrive soon. So if they arrive, I will have to go, but I'm happy to stay in the meantime.
Thank you. So Aaron just came up on stage. He's been listening for a while, and I'd like to give him the opportunity to speak.
Yes, thanks for this great talk. It's really interesting about how images amplify these biases. I'm curious if you're looking at generative AI, especially now that people are doing generative AI headshots, generative AI to make these people look better on social media. I'm curious if you've looked into whether, to what extent generative AI, especially in terms of enhancing images, how that affects gender bias and whether that's a good area to explore next.
Yeah, you're exactly right. So we have looked into that, and we've actually shown that basically the same biases show up in these AI models. And actually, right because it was such a fast moving space, many other research teams simultaneously uncovered this. And one of the findings, actually, they look at a much smaller scale. Part of the appeal of our Nature paper was we were the first to really look at many, many images across many, many categories. And we were also the first to compare against textual data. But one of the papers looking at this AI actually, they looked at just a few categories, but they compared the text to image AI models to Google Images. They found gender bias in both, but they found that the gender biases were even stronger in the AI models. And that was not just looking at the frequency, like how, female or male typed a given category is, but it was also in terms of how the person was presented. So, like you said, the stylized images. So, women were much more likely to appear with airbrushing and highly, like almost like models. So there were other aspects of bias showing up. And in our paper, like I mentioned, the gendered age bias result, we've been able to find very clear evidence of that bias in the AI models as well. And this is very concerning because, this move towards images is being accelerated by these AI models. People are able to produce many, many more images for their blogs, for their websites, for their own, like you said, people are using these AI generated headshots. And so we're increasingly entering into an image centric and AI mediated visual world. And so the fact that these tools have these intensified biases is really setting them up to spread these biases at a very large scale. And that's really the punchline why we want people to raise, why we want our study to raise the alarm, because it really speaks to what some of these very present trends where they're pointing towards.
Thanks.
Yeah, go ahead, Aaron, if you have some last comment.
No, that was it. Thanks. I really appreciated your talk.
Yeah,
Thank you
so
so much,
yeah, I
Aaron.
think
Appreciate it.
I think that at this point we've got to thank Douglas for joining us. It was very these are great slides, and it's a succinct explanation and comments that you've given us. We'd like to invite you back here again in Quantum Photonics. I'm sure that a lot of people would still like to hear you, but it's also good to end it at this point because where people think they want more, but there is no more for now. But I'm sure that you will be coming back in quantum photonics. So, would you like to say some parting words before we close the room?
Well, first, just let me say thank you so much for having me. This has been really fun. I would be happy to come back to quantum photonics. Thank you, everyone, for showing up. It was awesome to see this crowd and to share my research with the broader public. It's actually a privilege. Academics, we much too often only get to present it to ourselves and very few people in industry. So, but this impacts all of our lives. It's everyday cultural changes that is affecting everybody, and also has ramifications for the technologies that are going to determine our future. So it was a great honor. Thank you for all the great questions. If people want to stay in touch, learn more about my research and the ongoing work we're doing, feel free to follow me on Twitter. Also, you can email me. Always happy to keep the conversation going.
Yeah, thank you so much, Doc. So, I'd like to pass the mic to Bob if he has some last comments before we give the mic to Darcel to help us close the room.
I expected good. I got great. This was spectacular, and I think on behalf of everybody in the audience, thank you so much.
Yeah,
Thank you,
thank
Bob.
you
Really
once
appreciate
again.
those kind words.
We'd like there is a comment here from Ilya. I thank you for this excellent topic and especially this week that we have on March 8th. So yeah, we will see you everyone. And I'd like to give the mic now to Darcel to help us close the room.
Thank you, Cecile, and thank you, Doctor, for a great room. To close the room, we're going to start our countdown from lucky number 6. Is everybody ready?
Ready?
Ready.
6,
6,
5,
Oh,
Aaron 5,
5.
Nas 4.
4.
Bob 3.
3 it is.
Cecile Dos Equis.
Dos Equis, please.
Good doctor, your numero uno. Call out our last number, please.
Numero uno.
Yeah, thank you so much, Douglas. See you back in quantum photonics. And of course, we are rooting for the developments and continuity of your work. Thank you so much. And good night, everybody. See you in the next rooms.